Hello everyone, I'm Wei Yan, a third-year doctor student at University of Florida, major in educational technology. Today my topic is exploring elementary students' debugging behaviors in a puzzle-based programming environment through a learning trajectory approach. I very appreciate my collaborator and my teammate contribute to this project. There were 3 research questions in this study. First, what types of debugging strategies are students exhibiting while engaged in the puzzle-based visual programming platform? Second, how can students' debugging strategies be mapped with a debugging learning trajectory? Third, what challenges do students exhibit while in the process of debugging? This study is a basic interpretive qualitative study. For data collection, we have 4 participants were involved in this study. We screencasting their program activities. Each participant will have 80 million video to do the analysis. The puzzle-based platform used in this study is code.org. For data analysis, we used the semantic analysis to conclude the theme from data and map those themes with debugging learning trajectory. The debugging learning trajectory was done by Rich's team in 2019, consisted with different consensus goals. Due to time limit, I only present the primary findings from my study. The first thing concluded by from the data was trial and error. This one mapped with 4 consensus goals. In the next slide, I will show how student debugging behavior mapped with outcomes can be used to decide whether or not there are errors. As you can see here, the student write codes and run the codes to test the to see the tested result, find the location of bugs. The second thing concluded from the data was step-by-step error elimination. The nature of this thing was students were able to track the written codes and figure out the location of the bug. This thing mapped with 4 consensus goals as well. In the next slide, I will show you how student debugging behaviors mapped with the 4 consensus goals. Step-by-step exclusion of instruction can help find and fix error. As you can see here, students wrote codes and used the step function. This is a function specific provided by the puzzle-based platform code.org. And this indicates students has the sense to track the written codes and figure out the location of bug. So this mapped with step-by-step exclusion of instruction can help find and fix error. There were several unanswered questions and my future directions. First, how do students utilize those strategies in different programming environment? Second, what's the difference between novice and expertise debugging behaviors? Third, the efficiency of using those debugging strategies during programming. Thank you for listening, and we can talk about the question and feedbacks now. Thank you.
Great, thank you so much, Wei. All right, so let's open it up for questions. If you want to stop sharing your screen, then we can see. There we go. So I'll ask a question. So you're identifying the debugging strategies and then you're mapping them to the consensus goal. Within a particular consensus goal on the trajectory, did you see like a range of different kinds of, so you have this question about novice versus expert. So like once you map to a specific consensus goal, how much variability did you see in the students and how they were demonstrating the use of those debugging strategies?
I can show my screen again for the first debugging strategies. I conclude from the data. Some students articulate the intermediate level of using debugging strategies, and some students articulate the advanced level of debugging strategies. So this is only for the using trial and error, and for the step-by-step error elimination, they only articulate the intermediate level of debugging.
That's interesting. I also feel like these learning trajectories, which some of the things that we've noticed, they don't we don't have a consensus goal for, but we see folks doing. And so I'm wondering whether we'll end up adding nodes to this. Like, for example, I'm sure everybody's seen this in your work when a student works on something and decides to completely abandon it and start over. That's not something that we write about very much in our papers, right? Because we don't really think about that as a debugging strategy, but it certainly is a strategy that it sometimes makes sense. So, yeah. All right, so Luis has a question. Do you want to ask or do you want me to read that?
Sure, I can ask. So in code.org, there are like little messages that tell learners what to do next and what to try next. How do you think that that scaffolding that code.org provides influence the debugging strategies of students?
That's a good finding. That's a good question. That's also a finding I conclude from the data. We found the students were able to use system-specific support like step function and hints from the system. So this gives students the hints while they meet challenging problems and promote the students to think about the process of debugging.